hearty welcome to You Too Can, a channel that will help you to succeed in examinations easily.
Good day. Today let us see another problem in RL transients. Okay, so go through this problem. Here in the circuit shown, S1 is closed at t equal to 0 and S2 is opened at t equal to 0.05 second. You have to find the transient current, that is after S2 is opened. You have to find the transient current. First let us see this circuit. Okay, so S1 is closed at t equal to 0. So first you have to close this switch S1. At that time, what is the position of switch S2? S2 is opened at t equal to 0.05 second only. So at t equal to 0, both the switches are in closed position. So remember this, at t equal to 0, when S1 is to be closed, S2 is also at closed position. So S1 and S2 are closed. After 0.05 seconds only S2 is opened. Okay, now at first S1 and S2 are closed. Now what is the circuit behavior? 400 volt, S1 is closed. So here there is 200 ohm, 100 ohm, 10 Henry, and this switch is also closed. A current I of t flows through the circuit. Okay, now this 200 ohms is shorted, so all the current flows through this path. So the 200 ohm is neglected, the current flows through this path only. So now the circuit becomes like this. Okay, 100 ohm, 10 Henry, excited by 400 volt. This is the circuit when both S1 and S2 are closed. Okay, understand the problem. Now you have to find the current through this I of t. This is an ordinary RL series circuit with initially relaxed condition, that is 400 volt excitation, 100 ohm resistor and 10 Henry inductor. Now what is the current I of t? I of t is equal to V by R into 1 minus e power minus R by LT. Okay, so V is 400, R is 100 into 1 minus e power minus R is 100, L is 10 t. It is equal to 4 into 1 minus e power minus 10 t. This is the current when both the switches are closed. After 0.05 second, S2 is opened. So S2 is opened after 0.05 second. And the current we are calculating after, that is 0.05 seconds, that is the previous condition or initial condition for the inductor when S2 is opened. Okay, so you have to find the current at 0.05 seconds. Okay, so 4 into 1 minus e power minus 10 into 0.05. Okay, so 1 minus e power minus 0.5. It is 10 into 0.05 is 0.5. That will be 0.393. That is 4 into 0.393. That will be equal to 1.574 amps. 1.574 amps. This is the current at 0.05 seconds, and this will be the current through the inductor when the switch S2 is opened after t equal to 0.05 seconds. So the current through the inductor initial condition is 1.574 amps. Okay. Now the switch S2 is opened at t equal to 0.05 second. Okay. Now what will be the circuit? Circuit is S1 is still kept closed. Okay. 400 volt. This is 200 ohm. 100 ohm. 10 Henry. Now the switch S2 is opened. This is the switch S2. Okay. Now switch S2 is opened means this 200 ohm is included in the circuit. Now you have to find the transient current. This is the question asked. Okay. Now before this, when the switch S2 is closed, a current flows through the circuit. That will be the initial current for this inductor. That is I0 is equal to 1.574 amps. Okay. Now you have to write KVL equations for this. That is, now the resistor, the switch is opened means this resistor is present in the circuit. Now what will be the total resistance? These two resistances are in series. The switch is opened. Now 200 plus 100 adds up to 300 ohms. So the resistance of the circuit is 300 into I of t plus inductor is 10 di of t by dt will be equal to 400 volt. Okay. Now apply Laplace. So I of t becomes I of s plus Laplace of di of t by dt is s I of s minus I of 0, that is equal to 400, that is 400 by s. Now this previous value is 1.574 amps. Okay. Now 300 I of s plus 10 s I of s minus 1.574 into 10 is 15.74, that is equal to 400 by s. 300 I of s plus 10 s I of s equal to 400 by s plus 15.74. Take this I of s common outside, that is 300 plus 10s equal to, take LCM here, s is the LCM, so 400 plus 15.74s. Now find I of s. I of s is equal to 400 plus 15.74s divided by s into 300 plus 10s. So you have to take this 10 outside for making this as s plus something. So take the 10 outside, 400 plus 15.74s divided by 10 into s into, if we take 10 outside, it will become s plus 300 by 10, that is 30, and 400 plus 15.74 divided by 10 means it will become 40 plus 1.574s divided by s into s plus 30, that is I of s. Now apply partial fraction. Now I of s is equal to 40 plus 1.574s by s into s plus 30 will be equal to a by s plus b by s plus 30, which is 40 plus 1.574s by s into s plus 30 equal to a into s plus 30 plus bs divided by s into s plus 30. Cancel this. Compare s term. S term is a plus b. Here it is 1.574. And compare constant term. 30a will be equal to 40. Now a equal to 40 by 30. 40 by 30 is 1.333 and a plus b equal to 1.574. So that b equal to 1.574 minus a, that is 1.574 minus 1.33, which will be 4.244. So b is 0.244 and a is 1.333. Substitute in the previous equation. I of s is equal to a by s plus b by s plus 30. That is a is 1.333 by s plus b is 0.244 by s plus 30. Now take Laplace inverse, that is I of t. Laplace inverse is 1.33 by s is 1.333 plus 0.244 e power minus 30t. Okay. Hope you all are familiar with RL transients. That's all regarding RL DC transients. In the next video lecture, we will see about RC transients. Do more problems for homework as homework and study. Okay, thank you.